So today, Shabab, we will continue on factoring polynomials of higher degrees. And I think we reached this example. Let's read this example. What does it say, Shabab? Do each of the following for the polynomial of x. He wants me, first of all, to list all possible rational zeros. Now, do you remember what do we call this for, Shabab? Sorry, I have to restart this application. Just give me 1 minute. I will share the screen one more time. I think now you can see it, right?
Yes.
Right. Now he's asking me to find what in this example? List all possible rational zeros. Again, this number 4, do you remember what do we call it?
Constant.
We used to call this the constant term, sure. And the 8, what did we used to call it?
Coefficient.
The leading coefficient. Now, how do I find the possible rational zeros? We said we have to divide the factors of the constant term by the factors of the leading coefficient. Okay. Now, what are the factors of the constant term? The constant term is 4. Do you know what the factors of 4? We have plus minus 1, plus minus 2, and plus minus 4. Do we have any other factors for 4?
No.
We have to remember factor means if I divide, the remainder should be 0. Now, what are the factors of 8?
Plus 1.
Plus minus 1, plus minus 2, plus minus 4, and plus minus what? 8. Now I have to take all the possible divisions. If I divide all these by 1, what will the answer be?
The same.
Like, what if I divide them all by 2 now? Divide all of them by 2. 1 divided by 2
Have 1, 2.
is half. 1 and 2. 1 and 2, they are written, Shabab. We don't repeat them. What about if I divide them all by 4? 1 divided by 4 is 1 over 4. Then 2 divided by 4 is half. It's written. 4 divided by 4 is 1. It's already also written. What if I divide all by 8?
1 over 8.
Then 2 over 8, which is 1 over 4, it's written, right?
Yes.
Then 4 over 8, which is half, it's also written. So these are all the possible divisions. Now, how many possible rational zeros do we have?
3, 6.
No, we have 12. We have plus and minus. Am I right?
Yes.
Now, when I say possible rational zeros, this means the rational zeros can be from this set. So if I want to search for rational zeros, I have to search them from this set. Now, part B, what does it say, Shabab? Find all rational zeros and factor f of x into linear factors. Now we have to start searching for the zeros. From where do I search for the zeros? From the set that we have made earlier. So I have to start by finding f of what? What's my first possible zero?
1.
1. So I have to find f of 1. How can I find f of 1? We need to substitute in the given function. We have 8 minus 26 minus 27 plus 11 plus 4. Is this equal to 0, Shabab? It's obvious it's not 0. because we have large
not-
negative numbers. So this is not a 0. I will say what now? 1 is not what?
Factor.
A 0.
0.
I will go to the next number, which is what?
Negative
1. Substitute -1 in the function. We'll have 8 plus 26 minus 27 minus 11 plus 4. Let's add the positive numbers now. These are the positive numbers. Add the positives alone. What's the sum of the positive? 8 plus 26.
0.
34 plus 4 is 38.
34.
Add the negatives together. These negatives, if we add them, what do we get?
Negative 38.
So the answer is?
0.
So what do I say here? -1 is a 0. And what does that mean? It means that x plus 1 is a factor of f of x. Now, since we know one factor, how can we find the other factors, if you remember last time?
Division.
Thank you very much.
Division.
We will divide. So to find the other factors,
By division.
we divide. Of course, I will divide by synthetic division now. So I will use the synthetic division now. I will just put the division sign here. No, this is not the thing. No, let's do it one more time. Of course, we will divide by what now?
-1.
By -1. And the coefficients of the polynomial, I can take them from f of 1. We have 8, -26, -27, 11, and 4.
4.
Now let's divide.
Doctor, maybe they're missing.
No, there's nothing missing here. Go back to the question. Do you have any missing numbers? Look at them. 4, 3, 2, 1, 0. The powers. So there's nothing missing here. If there's something missing, we replace it by what we said.
0.
By 0. Now let's put here. What do I have? 8. -8. Negative what? 34. 34. 7. -7. 4. -4. And what's the remainder?
0.
And we said this 0 should be the same as this one. These should be the same. If it's not 0, this means there's a mistake in our calculations. So the other factor is this green thing, Shabab. This is our other factor. Don't forget the last number here is the constant. 7 is the coefficient of x. -34 is the coefficient of x squared. And 8 is the coefficient of x to power 3. So I will say that f of x is equal to what now? The first factor that we have found, which was x plus 1, multiplied by what? By this green thing. By this green thing, which is
8x power 3. -3, 34 x power 2. And plus 7x.
Now, Shabab, the given polynomial, what was the degree for the given polynomial?
4.
Degree 4. Now, what did I do here? What's the degree of the green?
3.
So I have reduced the degree inside each bracket. But now I have to factor more. This green thing, can I just name it as g of x?
Yes.
So I have to factor g of x now. How to factor it? Again, I have to search for zeros. But where should I search for the zeros? From the same set that we have found at the beginning. Remember the possible rational zeros?
Yes.
Now, when I used number 1, if you go back to the part B, the first line, when I used number 1, was the answer 0 here?
No.
So this means I'm not gonna check the number 1 again. If it's not a 0 from the beginning, it will not be a 0 also at the end. So don't check number 1. But -1 here, the -1, Did it give me a 0 or not?
Yes.
So this
Yes.
-1, I need to check it because it can be a repeated 0. So the first number that I have to check is what now?
8.
G of
-1.
-1. Put -1 inside G. What do I'm gonna write?
-8.
-8 minus
Plus
34
34.
minus 7 plus 4. And you can see obviously this is not 0 because we have again large negative numbers. So -1 did not succeed one more time. What's the next possible 0 in the list? We have +2 and -2. So let's find now G of what? G of 2. How can I find G of 2? We said there are two ways, either by the substitution or by the division. Which one is easier in this question? Substitution or division?
Division, because we have large numbers.
Yes, division is easier here. So let's divide by 2, Yashara. And let's see if the remainder is 0 or not. If the remainder is 0, this is what we need. If it's not 0, this means we have to search for another one. So let's put the numbers. We have what? 8. Let me just remove this. Then -34, 7, and 4. And we'll divide by 2. So what will I have? 8, 16, -18, -36, -29, -58, and this is -55. Is the remainder 0 or not?
No,
Not.
So what do I say? That G of 2,
it's not 0. Oh,
so 2 is not a 0. So I would say this is not 0. So I have to search for another one. Can I search for the next, which is -2?
Yes.
So I'm just going to use the same division, but I'm going to erase the values for 2. Yeah, let's divide by -2 now. What do we have? 8, -16, -50, 100, 107. It's obvious that it's not 0. So again, G of -2 is not 0. So I have to go to what now? To my next possible 0. What's the next possible 0 after these? Go here on the top. Go to this set, Chilla.
4.
4. I will try 4 now. Hopefully that 4 is a 0. Now you may tell me that the calculations are long. Is there a shorter way? Well, unfortunately, the answer is no. So we have to find now the 4. Divide by 4. What do we get? 8,
4.
32,
Negative.
-2, -8, -1, -4. Excellent. Did we reach a 0 or not?
Yes.
Yes.
So we say what now? X minus 4 is a
0 of action.
factor of f of x. Of course, the other factor is this thing. This is our next factor. So I will say f of x is equal to what now? Earlier in the previous step, we found x plus 1 as a factor. Now we have another factor, which is x minus 4. And the last factor is what now? Is the yellow. This yellow, can I write it as a polynomial as 8x squared minus 2x minus 1?
Yes.
Now, can I factor more this thing? The yellow part?
Yes.
We say this is 4x 2x minus, or sorry, plus 1 and minus 1. So now, if I ask Shabab, what's the power of x inside each bracket?
1.
So what do we call these? We call them linear factors. And the question at the beginning was asking me for what? Find the rational zeros. So what are the zeros now? At the end, what are my zeros?
X equal -1. 4.
Negative 1.
4.
4.
-1.
Negative
-1 over 4 and
Half.
1 of
half. Now this polynomial was what degree? What was the degree in my polynomial, Shabab?
4.
Look how long was the solution. Now what if the polynomial was of degree 5?
Will take more.
I have to repeat the division one more time. And if the degree is 6, I have to repeat the division 4 times, etc. So this is not a short method. If you have a question, raise your hand. Nothing? Abdul Khaliq.
Yes, why you didn't complete?
Can you repeat?
Why you didn't complete?
Complete what?
يعني لما تكمل الباقي الزيروز.
I found all the zeros here. خلاص. I'm factoring. If I factor, I found all the zeros. Did I factor? I said at the end here, what's the power of each x here inside each bracket? What's the power of x inside each bracket?
1.
So this is now the last step of factoring. Now I will find the zeros by making each bracket equal to 0. And we said these are what now in the question? These are possible zeros. But since the degree was 4, degree was 4 or not?
Yes.
If the degree is 4, Shabab, we will take a theorem right now that the number of distinct zeros will not exceed 4. So it's impossible to have 5 zeros. The number of zeros should be at most 4. But why I didn't check the remaining? Because factoring made things easier for me. Is it easier for you to factor or to search for the zeros one by one?
To factor.
Yes, factoring is easier here. Any other questions? Fine. Now we have the number of zeros, as we said earlier. Let's read the first one. What does it say? The fundamental theorem of algebra. It says every function defined by a polynomial of degree 1 or more has, read this is very important, has what? At least one complex zero. And when I say complex, it includes also the real numbers. Why? Because we know that every real number is a complex number. So if I have a polynomial of degree 3, let's say, what's the least possible number of zeros for that polynomial?
3.
The least. The least number of zeros is 1. This means any polynomial should have at least one complex zero. So there is no polynomial with no zeros. At least we have 1 0. This 0 can be complex. Type. The second theorem now, what does it say? A function defined by polynomial of degree what? What's the degree now?
N.
Degree n has what? At most n distinct zeros. What does it mean distinct in Arabic?
maximum يعني.
Distinct, what does it mean in Arabic? مختلفة. So now the degree and the number of zeros should not exceed the degree. So again, if I have a polynomial of degree 4, how many distinct zeros can we have?
4.
At
4.
most 4. At most 4. So they can be 4 or less. So the number of zeros for a polynomial will be from 1 to n, and n is the degree. So let's say we have a polynomial of degree 6, Shabab. If we have a polynomial of degree 6, how many zeros can we have?
6.
From 1 to 6. We can have 1, we can have 2, we can have 3, we can have 4, we can have 5, we can have 6. But can we have 7 zeros for a polynomial of degree 6?
No.
The answer is no. So the number of zeros is either between 1 and the degree. Okay? The next example is, sorry, we have another rule here, and this is a definition, by the way. Read this definition. What does it say, Shabab? The number of times a zero occurs is referred to as the multiplicity of the zero. First of all, what does it mean, occur? It means appear. What does it mean, appear?
يظهر.
يظهر. So the number of times you see a zero, we call it what? Read, what do we call it? The multiplicity. So if you hear the word multiplicity, it means how many times you will see the zero. Let's take an easy example for that. He says find the zeros and their what? And their multiplicity. Now, Shabab, first, is this polynomial factored or not?
Yes.
Why
I
is
think-
it completely factored? Or should I factor it more?
You can.
What's the power of x inside each bracket?
1.
If it's 1, this means this thing is completely factored. We cannot factor it more. But if the degree inside one of the brackets was not 1, it means we have to factor it more. Okay? So this is already factored. Now, what's the zero of the first bracket?
2
2.
Or the second bracket?
with 1.
-1.
-1. And for the last bracket?
-√5 plus.
That's right. So the first zero is what here? Is 2. Do you know what's the multiplicity of that 2? How many times will I see that 2?
3 times.
I think we'll see 3 times. Why 3 times?
Power 3.
Because the
Okay.
power is 3. Power 3 means the bracket will be repeated 3 times. So I can say that the power of the bracket is called what now? The multiplicity. What's the zero of my second bracket?
-1.
-1. What's the
-1.
power of that?
2.
2
And what's the zero of my last
So-
bracket? This thing. If I say x minus 2 plus √5 is 0, how much is x? Can I say x is 2 minus √5?
Yes.
So -√5.
And what's the power?
1.
1.
So the multiplicity is 1. So in simple words, the multiplicity is the power of the linear factor. Any questions? Right. Let's take one more example on the same idea. This one now, read it. What does it say? Find all zeros and their multiplicity. First of all, Shabab, inside each bracket, do we have linear expressions or not?
The first one, no.
The first one is no. So what should I do for the first one?
Factor.
We have to factor it. How do we factor the first one?
X plus X
plus 2
plus
minus
2
1.
and X minus 1.
But we have a power of 3, and this power of 3, I should give it to both. What about the second bracket? What's the power of x?
2.
No, the power of x which is inside. I'm talking about inside the bracket.
1.
So this is what now? Factored. Now I want each one of you to find the multiplicity of each one of these zeros. Or I will just start asking now mentally. Hussam, are you with us? Hussam, are you here? No, Hussam is absent today. Yeah, good for him. Kamal. Give us the zero, Kamal. Who's laughing?
No one.
Is there something to make you laugh? What are the zeros here, Kamal? The first zero, what is it?
-2.
-2. Thank you. What's the multiplicity?
3.
Thank you very much. Samer, the
Yes.
next zero.
1 and the multiplicity is 3.
Thank you. Nasser, the next zero.
0 1 minus the other 3 and 2.
The multiplicity is
2.
2. Thank you. Again, if you have a question, raise your hand. Type. Let's continue now. Go back to what we were talking about. Let me search for another question so that we can solve it. Okay, sorry, there's the application is not responding. Just give it 1 minute to respond. Type. It's not responding at all. I will just restart this application. Okay. Type. Now let's read this example. This is an old exam, Shabab. This is an A+ question. Read, what does it say? If 2 is a zero of multiplicity 2 of this polynomial, find the values of what? Of A and B. Now when he says 2 is a zero, what will the remainder be if I divide?
0.
The remainder should be 0, right? But when he says the multiplicity is 2, it means I have to divide by this 2 times. Why should I divide 2 times? Because he said the multiplicity is what? So I will divide by 2 times. Why 2 times? Because he said the multiplicity is 2. And of course, in both divisions, if I divide, what should the remainder be?
0.
0. And if the remainder is not 0, there is something wrong. So let's start dividing now. I will divide 2 times. We have 1, then A, then 8, then -16, and at the end we have B. Let's start with the first one. 1, we have 2. How can I add A and 2? Can I say A plus 2?
Yes.
Then multiply A plus 2 by 2. We have 2A plus 4. Add, I'll have 2A plus what?
12.
Plus 12. Multiply 2A plus 12 by 2. 4A plus 24. Add them. We have 4A plus what? Plus 8. Multiply 4A plus 8 by 2. We'll get what? 8A plus 16. Add, what's the answer? 8A plus B plus 16. Leave this for 1 minute. This is now. This is the remainder, right?
Yes.
And we said this remainder should be what?
0.
So can I say that 8A plus B plus 16 is 0 or not?
Yes.
Now let's divide one more time. Put 1 down. 1 times 2 is 2. We have A plus 4. Multiply by 2. What do we get?
2A plus 4.
2A plus 8.
2 plus 8.
So we have 4A plus 20. Multiply by 2. We have what? 8A plus 40.
8A plus
This will be
40.
12A plus 48. This is our next remainder, the other remainder. Also, we said this remainder should be what?
0.
0.
Should be 0. So can I say that now 12A plus 48 is equal to 0?
Yes.
But now, Shabab, I made two remainders. In the first remainder, we have two variables, which are a and b. In the second remainder, we have only one variable, which is a. Now, which one is easier to start with? With one variable?
The first. The first.
One variable or two variables?
One.
One variable.
So how much is a in the one variable? Can I say a is negative 48 over 12?
Yes.
Negative 4.
Which is negative 4. Now I will use this negative 4 in the second one. I will say 8 multiplied by negative 4 plus b plus 16 is 0. Can I
0.
find b?
Yes.
b will be
16.
16. Again, as I said, this was an old exam, an A plus question, or an A question at least.
Doctor,
Yes.
if the multiplicity is 4, maybe we do it 4 times.
Yes, you do it 4 times. Type. If this is okay and understood, let's go back to the opposite now. We will learn how to find a polynomial if we know the zeros. Read this example. What does it say, Shabab? Find a function f defined by a polynomial of degree 3 that satisfies the given conditions. A, the zeros are negative 3, negative 2, and 5. And f of negative 1 is 6. Now the question is asking me to do what, Shabab? Find what? A function that is a polynomial of degree what?
3.
Degree 3. Now how many zeros are we given in this example?
3.
So if I want to make my polynomial, I will open 3 brackets for that. Why 3 brackets? Because I know 3 zeros. And inside each bracket, we can write x minus, and x minus. And what's our first zero?
Plus 3.
Negative 3. And the
X,
second is negative
plus
2. And the last is?
Negative.
So if I multiply all these, they will give me the polynomial with these zeros. But here, we have to multiply by a. And that a, if you remember, is the leading coefficient. So now, our last step in this question is to find the value of a. How can we find the value of a? I will use this order pair that is given to us. He gave us that f of negative 1 is 6, right?
Yes.
Yes.
Which means I can replace y by 6 and x by what?
Negative 1.
Negative 1.
So now I can find the value of a. Let's simplify these to see how much is a. This is 2 times 1 times negative 6. So can I say that a is 6 over negative 12, which
Yes.
is?
Negative half.
Negative half.
So what's my function in this case?
Negative half.
Negative half multiplied by the 3 brackets.
X
Now,
plus 3.
should we multiply the brackets or should we leave them? Well, it depends on the choices that he gives you in the exam. If he's expanding, you need to expand. If he's leaving them like this, you will leave them. I'm not going to expand here. I have taught you in chapter P how to expand. Raise your hand if you have a question. And leave your camera open, Shabab. No questions? I want you to do this one. Solve this one for me. He said 4 is a zero of multiplicity 3. So how many zeros do we know right now?
1.
1 0. So how many brackets we will make?
3.
3.
1 bracket with power of? Yeah, let's start. Make a function here. Don't forget the multiplicity. We will put it as a power. Excellent, Osama. Let's do it together now. Now, what should I write inside the brackets? X minus what? And the power should be 3. Now, to find the value of A, I'm going to use the given order pair. So I will replace f of x by negative 24 and x by what? By 2. So we say negative 24 is equal to what? A multiplied by what, Shabab, this thing is?
Negative 2.
Negative 8, because negative 2 to power 3. So A is what now? Negative 24 over negative 8, which is?
3.
So what's my polynomial now? It's 3 multiplied by x minus 4 all to power 3. Again, you can expand if the question is asking you to do that. Now let's move to the next part of this lesson, which is the conjugate zeros theorem. Let's read it. This is a very important theorem and solve some questions on it. What does it say now? Do you remember the word conjugate? What does it mean? Conjugate.
In Arabic,
Murafaq, yes. Are these conjugates now, Shabab? Look at them, a plus bi and a minus bi.
Yes.
So let's read the theorem. What does it say? If f of x defines a polynomial function, so this is a polynomial now, having only, this is very important, having only what? This is very important, Shabab. What does that mean? All the coefficients should be real. And if z equals a plus bi is a 0 of f of x, then a minus bi is also what? As 0. What does that mean, Shabab? If one of the zeros is a complex number, automatically the conjugate of that complex number is also a 0. But this is only true if the coefficients of the function or the variables in the function are real. Can we make a justification, justify or say why should the conjugates be both of them zeros? Do you remember the quadratic formula, Shabab?
x squared.
X equals negative v plus minus root of b squared minus 4ac all over what?
Squared.
Now, if I want to write them in separated form, we will take the positive part alone and the negative one alone. Do you see anything, any relation between these, Shabab? Look at the root.
Yes.
We have a positive and we have what?
Negative.
So if the zeros or the roots are complex, what's the only difference between them if they are complex? The only difference are in the just the sign plus minus. Are these conjugates or not?
Yeah.
Are these conjugates,
Yes.
So that's why we say if one of the zeros is complex, automatically its conjugate is also a 0 because of the quadratic formula. But again, I repeat, this is true only if all the coefficients of the variables are real. Let's take an example on this. What does he say in the next example? Find what? A polynomial function f of x of least degree, having only, read this, this is very important, having only what?
Really?
Real coefficients. And zeros, -4 and 3 minus I. Do you see the 3 minus I, Shabab? So can I say that also 3 plus I is a 0?
Yes.
Why?
From the theorem.
From the theorem. And don't forget, because we have what? Real coefficients only. So in total now, how many zeros do we know?
3.
So if I want to form my polynomial, how many brackets will I open?
3.
3 brackets. And of course, outside I will multiply by what? By a. So what's inside now? X minus, x minus, x minus. And the first one, what should I write?
4.
Plus 4. In the second one, what should I write, Shabab? I will say this is 3 minus I. And the last one?
3.
3 plus I. Now I will teach you how to expand this, because this is critical. Do you remember that we have taken a formula for the quadratic like this? X squared minus the sum multiplied by x plus the product.
Yes.
So I can use this in my example here. Of course, I will leave a as it is. Now, what's the sum, ya shabab, of the complex zeros?
6.
So I will say this is minus 6x. And what's the product of the complex zeros? How much is 3 minus I multiplied by 3 plus I?
9 plus 1.
Which is?
10.
So this is the how to multiply these brackets. Now, of course, you can continue multiplying by x plus 4, but I think this is an easy stuff. But now the question is, can I know a?
No.
So here we are not given, there is no information about the value of a, which means that a can be any non-zero real number. What does that mean, Shabab? And in the exam, if he put, instead of a, if he puts 1, will you accept it?
Yes.
The answer is yes. If he puts a equal to 2, will we accept it?
Yes.
So here, he can use any value for a. If he removes a, this means the value of a is equal to what?
1.
1. So should we accept that or reject it? In this question, we will accept it because he didn't give me any point to find the value of a. If you have a question. Type nothing, we'll move on. Read this. What does this example say now? He says find what, Tisha?
All 0.
All zeros. Given that 2 plus I is what?
0.
Now look at the coefficients, Shabab. Are all the coefficients real numbers or not?
Yes.
So we'll say
Yes.
since all the coefficients are real numbers, what can we say in this case?
2 plus I is 0 and 2 minus I is 0.
Thank you very much. 2 minus I is also. So how many zeros do we know in total?
4 and 2 missing.
We know 2 and we are missing 2, so we have to find these 2. How can we find the missing zeros?
can divide.
Thank you very much. So to find the other zeros, we need what? To divide. طب should I divide by what? By 2 plus I or 2 minus I?
I think
Yeah.
nothing. The same.
Well, we have to divide by both of them, Misha. One by one. So I will make how many divisions? We will make 2 divisions now. The first division I will divide by the given one, which is 2 plus I. And in the second one, we will divide by the conjugate, which is 2 minus I. But here, since we are using complex numbers, we have to be very careful. And we have to make some spaces between the numbers. Yeah. Let's start the division now. I will put 1 now. Multiply 2 plus I by 1. It's 2 plus I. Add. The answer is 1 plus I. What's our next step now?
Multiply 1 plus I with 2 plus I.
Thank you. If we multiply, what do we get? 2 plus I plus 2I minus 1. Should I say 1 plus 3I?
Yes.
So this is 1 plus 3I. Add them now, we get negative 16 plus 3I. What's our next multiplication now? 2 plus I times negative 16 plus 3I. If we multiply 2 by negative 16 is negative 32 plus 6I minus 16I minus 3. Can we simplify this? Can I say this is negative 35 minus 10I?
Yes.
Add now, we have what? 20 minus. So the last multiplication that we'll do here is to multiply 2 plus I by what?
20 negative
20 minus
10i.
10I. Multiply, we have 40 minus 20I plus 20I plus 10. And the answer is what? 50. Add now, what do we get?
0.
0.
0.
And
Remember,
of course,
it's 0.
if it's not 0, it means there is something wrong. What's our next division now? Sorry. We have to divide by what now, Shabab?
2 negative I.
By 2 minus I. And again, the remainder should be what?
0.
0.
And if the remainder was not 0, this means again there's something wrong. So let's divide by that. We have what now? 1. Then we have 2 minus I. Add, we get
3.
3. 2 minus I times 3
6.
is
Negative
6 minus 3I.
I.
Add, we have negative
And
10. Multiply by 2 minus I. It's negative 20 plus. Is the remainder
I.
0 or not?
Yes.
10i.
No. Now we are dividing to find this factor. This is the other factor that we are looking for. So how can I write my polynomial now?
0.
Can I say the following now, that f of x is equal to what?
2 plus I and
X minus
2
2
negative
plus
5.
I. X minus 2 minus I multiplied by the green one. And what's this green one?
x squared.
2
X squared plus
6
3x.
minus 10.
Can we factor this green thing?
Yes. X minus 2x plus 5.
Thank you very much. And we are done. So this is x minus 2 and x plus 5. So what are the zeros for this polynomial? What are the zeros, Shabab? We have 2 plus I, 2 minus I,
2
and
negative
what?
5.
2 and
5.
negative
5.
So how many zeros in total do we have?
4.
4.
Don't forget, what was the degree?
4.
That's it. Okay, we'll stop here today. We have just a small part in this lesson. We can finish it on Thursday. Don't leave. Don't leave, ya shabab. Don't forget on